Time for some e-learning with Miss Atkin. E-learning with Miss Atkin. E-learning with the puppy. E-learning with Miss Atkin. Yeah.
What's up, scholars? Today we are continuing our investigation of angle relationships with circles. We've got 3 more theorems to talk about today. So for this very first one, please draw for me a circle. Excellent. And then we're going to draw a line tangent to the circle, meaning it only intersects the circle at one place. Let's call that point of intersection A. And then let's draw a chord from A to the other side of the circle. Anywhere would do. Let's call that point of intersection B. And let's give ourselves one more point over here, C. And then we're going to label 2 angles. We'll have this angle here will be angle number 1. And this angle here, angle number 2. Okay, cool. So we know that the measure of angle 1 plus the measure of angle 2 equals 180 because they make a straight line. Those guys are called a linear pair. And we also know the total number of degrees all the way around a circle for its arc would be 360 degrees. So our straight line, 180, and all the arc measures in a circle add up to 360 degrees. So, this theorem should make some intuitive sense here. It's going to say that the measure of each of these angles is 1/2 their intercepted arc. So, the measure of angle 1 is going to be 1/2 the measure of arc AB, and the measure of angle 2 is going to be 1/2 its intercepted arc. Angle 2 has an intercepted arc of the big one here. So arc ACB, 1/2 the measure of arc ACB. Cool. Let's do a couple examples with that sucker. So here's our first example. We have this line tangent to a circle. It intersects at exactly one place. We have a chord, RT. We've got an angle made from this tangent and this chord that's 115 degrees. So we can use the theorem we just talked about above. Now clearly, this angle intercepts a big arc. So we're going to look at this second one here. So we'll say the measure of this angle, which is 115 degrees, is 1/2 of the measure of arc RST. So if we want to find the measure of RST, multiply both sides of the equation, by 2, and that 1/2 and that 2 cancel out. So we get the measure of arc RST is equal to 2 times 115, which is 230 degrees. Nice. Let's do another one. So here's our next example. We have this line tangent to the circle. It intersects at one point, which is B. We've got a chord BD. We see that the arc here measures 140 degrees, and we're going to find the measure of angle CBD. So this is the measure that we're looking for. Cool. We can use our theorem. It's going to say the measure of this angle, the measure of angle CBD is half of the intercepted arc. That intercepted arc is 104 degrees. So it's 1/2 of 104. So the measure of angle CBD is 1/2 of 104, which is 52 degrees. Nicely done. All right, that's theorem number 1. Let's move on to theorem 2 of this video. And for the second theorem, of course, let's start out drawing a circle. And now let's draw two chords that intersect somewhere in the middle of our circle. Call that guy. Well, let's just draw the chords first. Cool. Let's give them some names. Call that A and B and C and D. And then we've made 4 different angles, but we know we only have 2 different angle measures because the vertical angles here are congruent. So let's just put a number 1 right here and number 2 right here. So we're talking about this angle and that angle. Fabulous. Now this next theorem says if you have 2 chords that intersect on the inside of a circle, then the measure of each of these angles, so the measure of angle 1, is equal to 1/2 of the arc it intercepts and the arc its vertical angle intercepts. So let's write that out. The measure of angle 1 is equal to 1/2 the measure of the angle that, the measure of the arc that that angle intercepts, AB, plus the measure of the arc that its vertical angle intercepts, DC. So it's going to be 1/2 the measure of AB plus the measure of arc DC. And by that same logic, the measure of angle 2 is going to be 1/2 the measure of the arc it intercepts, BC, measure of BC, plus the arc its vertical angle intercepts, AD. Cool. I think it's time for some examples. Alright, so here's our first example. We've got this angle that is x degrees right here. And that angle intercepts arc AB. Its vertical angle intercepts arc CD. So we can use the theorem that we just talked about. The measure of this angle, which is x degrees. X is going to equal 1/2 the measure of the arc it intercepts plus the arc its vertical angle intercepts. So the measure of AB plus the measure of CD. Almost running off the page there. Doing great. Fabulous. So x equals 1/2. AB is 60. CD is 20. So x equals 1/2 of 80. So x equals 40. Cool. Alright, one more for good measure. Here's our second question. We've got 2 chords again. I didn't even bother labeling their points of intersection, but I'm pretty sure we're going to be able to figure this out. We have an angle on the inside is 45 degrees. We have its intercepted arc, which is 2x degrees, and its vertical angle's intercepted arc, which is x degrees. Same question, we're going to find x. But this time, we know the measure of the angle, so we know 45 degrees is equal to 1/2 the measure of its intercepted arc, which is 2x, plus the measure of its vertical angle's intercepted arc, which is x. So we've got 45 is equal to 1/2. 2x plus x is 3x. All right, we could do 1/2 times 3 and get 1.5. Or we can multiply both sides by 2, which is what I'm going to do. Get rid of that fraction. I know 2 times 45 is 90 equals 3x. Divide by 3. And we get x equals 30. Super chouette. Très bien. Bon. We have one more theorem for this video. It's going to look a couple different ways, but the premise is the same. So let's check it out. All right, last one. Here we go. Go ahead and draw a circle. Draw a tangent to the circle. Now, for simplicity, don't keep drawing that forever. Instead, from this end of your tangent, draw a secant here. Secant means it has 2 points of intersection. So we've made an angle where one side of the angle is tangent, one side of the angle is a secant to a circle. Let's call this angle 1. And let's give these points of intersection some names. Let's do A and B and C. Now this theorem says we've got an angle that's external to the circle. The measure of this angle is going to be half of the difference between the intercepted arcs. So this angle intercepts this arc here. Actually, let's give it another letter, because that looks like a major arc. Yep, it intercepts this arc here, and it intercepts this arc here. So the measure of angle 1 is going to be half of the difference between the measure of this arc, CDB, and the measure of arc AB. The measure of angle 1 is half of the difference between the measure of arc CDB minus the measure of arc AB. Cool. So now I said this same theorem is going to look 3 different ways. So let's talk about all 3 of those ways. So we had a tangent and a secant. Let's draw ourselves another circle. This time let's have an external angle that has 2 secants, meaning it goes through the circle. Each of these rays go through the circle twice. Let's put some letters here. Let's do some different letters. E, F, G, and H. And now we'll call this angle 2. So same idea. This external angle, the measure of angle 2, is going to be equal to the difference of the intercepted arcs. So this angle intercepts arc FG and arc EH. So the measure of angle 2 is going to be equal to half of the measure of FG, arc FG, minus the measure of arc EH. Cool. So again, still subtracting. We're always going to subtract the big one minus the little one, the big one minus the little one. And finally, our third form. So of course, start with a circle. This time we're going to have 2 tangents that make an exterior angle. Ooh. That should be a tangent. Hopefully your drawing is prettier than mine. Okay, so this is going to be angle 3. Angle 3 intercepts this large arc here, so it's going to need another point, and the smaller arc here, so intercepts a major arc and a minor arc. Let's give these guys some letters. Let's do X, Y, and Z. It's going to be the same idea. So the measure of angle 3 is going to equal to half of the measure of X, Y, Z minus X, Z. The measure of angle 3 equals 1/2 of the measure of arc X, Y, Z minus the measure of arc X, Z. Cool. Alright, I think you know what time it is. Example time. Alright, here's our first example. We have an external angle, exterior angle X, which we'll be solving for. We have an intercepted arc here that's 136 degrees. We have another intercepted arc here that's 38 degrees. So this looks like situation number 2. So the measure of our angle X is going to be 1/2 of 136 minus 38. So X is going to equal 1/2 of 136 minus 38. So X is going to equal 1/2 of 98. So X is going to equal 49. Nice. Very nice. Alright, one more example for us, and that will be the end of this video. For this last example, made it tricky. This looks like an ice cream cone, doesn't it? Yes, it does. So these are tangents. We have an exterior angle that's 45 degrees. We have an intercepted arc here that's X degrees. What the devil is this one? Ooh. Well, let's say, for example, X was 60 degrees. What would this guy be? 300 degrees, because the whole thing has to add up to 360. So that must mean that this big arc over here is 360 minus X degrees. Now we can do this. This looks like situation number 3. So this says that the angle on the outside, which is our 45 degrees, is equal to 1/2 the big arc, which is 360 minus X, 360 minus X, minus the little arc, which is X. And now we can solve. We've got 45 equals 1/2. 360 minus X means 360 minus 2X. And again, well, we can multiply by 1/2. That's not too bad here. Could also multiply by the reciprocal 2 and get rid of it, but multiplying by half's not bad, because we know half of 360, that's 180. And we know half of -2, that's -1. That wasn't too bad at all. Not too bad at all. Alright, let's subtract 180 on both sides. We'll get -135 equals -X, which means, when we divide by -1, we shall get that X equals 135. Cool beans. Sweet, yo. That was a good time, wasn't it? I enjoyed myself. I hope you did too. Alright, I love you, scholars. I will see you next time. Please come hang out with me in office hours, and let's do some math together. Peace.